So we will be starting with the introduction to quantum mechanics, and the book that we follow will be the same, Introduction to Quantum Mechanics, the second edition by David John Griffiths. So this is the second edition of this book, and we will follow this one. But before starting with the quantum mechanics, we should study the reason for quantum mechanics. Why we need to study quantum mechanics? Because this is a new subject, and the new subject also requires the reason for it. What's the need of it? Let me start from the Greek philosophers. You know, they were concerned about the nature of matter. What is matter, what it is made of. So, if I consider a piece of anything, when it is metal, so a piece of anything, for example, wood or metal or plastic, polymer, whatever piece I consider, then I know that it is made of something. So what is that something? You know that Democritus, which we call Democrates, he gave the concept of atomos and said that this is a finite splitting. Atomos, finite splitting. Finite splitting means that if you take a matter and you are breaking it, finally you will reach the basic entity of that material, which you will call the atomos. Means it is a finite splitting. After that level, further splitting will not be possible. And Aristotle, which you call Aristotle, he said that there is no limit on the splitting, like infinite splitting. Splitting will not stop. There will be no building block, like as you are going in, that thing will be able to split and so on. So this is in infinite splitting. At that time, people were also concerned about that how to turn silver into gold. Because you know gold is very precious. At that time, no concept of platinum, which you call the white gold, but how to convert silver into gold. They tried a lot, but they didn't succeed. And then they came to know that yes, this thing cannot be done. You cannot convert one element into another. This thing is not possible. So they came to know about this fact. Then the known history came in, and in 1803, John Dalton, he said few things. And the very first thing that he said was that matter is composed of atoms. This name was given by him. Matter is composed of atoms. means some atoms actually combine with each other and they constitute matter. And the other things, he said that all atoms of a material, means single material, are identical. They will be the same, means same atoms will actually make that material. And then different elements will have different atoms. They will not be the same atoms. So when they will be different atoms, then it means that they will have different weights as well. And the concept of atomic weight came into existence. That different atoms will weigh different. Means the mass of one atom will not be the same as the mass of another atom. And the final thing that he observed was that atoms combine in simple ratios, to form a molecule. Like for example, you say H2O. So two hydrogen and one oxygen, they combine and they make water. Similarly, like HCl. So two atoms with 1:1 proportion, 1:1 ratio. Here 2:1 ratio combine and they form a molecule. So this was the findings of John Dalton almost 200 years back. He actually said this thing. And then there was a person in almost after 100 years, 1897, when the 20th century was about to start. So it was J.J. Thomson. You know, J.J. Thomson performed a very basic experiment, and he said that what he did, actually he took a chamber, means a chamber made of glass, like a glass liquid, and he put in this one the hydrogen gas, H2. And he applied electric field here. Like in this one, it was a hot hydrogen gas, and he applied potential there, very high potential. And when he applied field vertical to it, he observed that some of these gas particles are actually going there. So if it was a positive plate and particles started going there, it means that these particles are actually negatively charged particles. That's why they are going to the positive plate. And he gave the concept of plum pudding model. You have seen plum, the cake piece, in which the puddings, means in that one, the fruits, they are in different places fixed in there, like the kishmish, a cake. So they are this may be a peanut or other you can say fruits. They are in some places in it. So what he concluded that actually atom is something which is composed, means atom is neutral. So it means that it is composed of some negative and it is composed of some negative and positive charges, and they are fixed over there. Clear? This was called the plum pudding models. It is a distribution. This distribution is such that they are fixed there and they are equal in number and they are neutralizing each other. So this model means the first introduced in 1897, and then you know that people observed in 1899, you know, means 2 years after this one, there was a person called Henry Becquerel. Henry Becquerel in 1899, 2 years after him, observed the phenomenon of radioactivity. You know what happens in radioactivity. He took a material which was radioactive, and out of that material he applied an electric field to those radiations, and there was a screen here. As these particles were emitted by this radioactive element, they were reaching here. So some particle struck there, some particle struck here, some particle here, while some particle reached this point. So it is a positive field, and some radiations are striking this one. It means they were negative in nature. That's why from here they were attracted by this field and they reached here, and those were termed as beta rays or beta particles. Okay? The one which reached here means they were positive in nature, so they were termed as alpha rays or alpha particles. And the one which didn't experience any electric field, it means they were neutral in nature, so they were called the gamma rays. So this was a concept with this one, that rays are particles and particles. This thing was observed that yes, in this model, in which there is minus, there is plus, and there is also some neutral thing over there as well. And then after almost 20 years, after the first decade of the 20th century, in 1911, a person, Rutherford, if you pronounce this in German, then this is Rutherford, but in English we say Rutherford. He performed an experiment with the help of his two students. One was Geiger and the other was Marsden. The Geiger and Marsden performed an experiment with their supervisor, Rutherford. You know this Geiger later on invented the Geiger counter, right? The counter he invented. So, in this one, what they did, they actually took a radioactive element which was radium bromide. It's a very toxic, very dangerous material, and it is highly radioactive. And this material is emitting alpha particles. Alpha means the positive one, because at that time it wasn't sure what is this alpha in nature, but it was emitting those positive rays. And what they did, their very famous experiment was that they took this RaBr2, radium bromide, and it was emitting particles, and they put a very, very thin foil of gold. It was very, very thin. Thin in the sense that very few atomic layers were there, because you know gold is very malleable, very soft, and it can be made very thin. So it was few atomic layers, and they bombarded these alpha particles on it, and the result was quite surprising. The result was that, let's say at this point they are striking, then these particles were actually deviated by this point, and means they were deflected this way or this way. They were blocked by this point, and it was like almost you are hitting an atom with alpha particle, and those particles actually deviate from it. It was like that you take this much big iron ball and you throw it on a tissue paper, and from the tissue paper it either goes this way or it is, you can say, bounced back by the tissue paper.